Hello and welcome to part 4 of our Java programming series. And this is a part of our continuing series, of which so far we have done 3 parts. If you have not watched the other parts, I'll leave the link in the description below. You can be able to watch all the other parts and then you can proceed to part 4. If you're here for the first time, please consider subscribing to the channel, like our videos, put your comments in the comment section, and we'll be glad to respond to them. And also, if you feel that there's any certain video that you'd like us to do for you, you can always reach out to us through our email. It's available in the channel description, and we'll be glad to do the video for you. So in our previous video, we talked about the scanner class and how you can be able to use the scanner class to capture values from the keyboard or allow users to input values directly rather than you defining some static values. That video is in the link below. You can be able to watch it. And now today we are proceeding from there and look at something known as control structures. So basically, we have been able to write basic programs that are just flowing from top to bottom without making any decisions or without evaluating any condition. And now it is time that we advance further and write programs that can be able to evaluate situations or conditions and behave in a certain way based on the situation or the condition that they have found. Now, this is what we call control structures, and control structures basically control the flow of a program. The very basic control structure is known as the sequential control structure, which is what you have been doing. A program just flows from top to bottom without branching anywhere. Then we have what we call the branching control structures. And branching control structures make a program to branch based on a decision. So there's a condition that is introduced whereby a program has to evaluate the condition, and based on whether the condition is true or false, the program is able to branch. And these branching control structures can be grouped into 3 main categories. We have the if control structure, we have the if-else control structure, and we have the multiple if-else control structure. We'll have a look at each one of them. Then we have what we call the looping control structures, and what they do is that they perform a certain set of actions a given number of times or until a certain condition is false. Some start by evaluating a condition, and then, so long as that condition is true, they perform a certain set of actions repeatedly until such a time when the condition becomes false. Others will first perform a set of action once, then evaluate the condition, and if the condition continues to be true, they will continue performing the set of actions repetitively until the condition becomes false. And loop structures include the while loop, the do while loop, and the for loop. On top of that, we have what we call the nested control structures. This is when you have a control structure inside another control structure. For instance, you have a loop structure inside a decision or a branching structure. And that one will come towards the very end of this part 5 of our video. But in this part 4, we are going to look at the decision control structures, starting with the basic one all the way up to the advanced ones. And we have said that the decision control structures can also be referred to as the branching control structures. The very basic decision control structure is known as the if control structure. Let us take a situation here. Let us declare a variable and say double num1, or we can just call it x, is equal to 10. So we can already see that the value of x is equal to 10. Now, what if we wanted to evaluate if this value of x is equal to 10, then we do something about it. Like, for example, we output that the value of x is 10. So you can come here and introduce a decision structure. As simple as this. You start with the keyword if to show that it is an if decision structure. Then you put some brackets. And then inside these brackets, you put the condition that you are evaluating. In this case, we want to evaluate whether x is less than or equal to 10. So we say x less than or equal to 10. Now, after we do that, we come here and we put some body of this particular decision structure. And the body of this decision structure, we define it using the opening and the closing curly brace over here. Then you can come here and say, if yes, x is less than or equal to 10, what do you want to do with x? Then we can say that we want to do this. We want to output. So we say system dot out dot print line. We want to output x is less than 10. We want to output that x is less than or equal to 10. So if we run this particular program, you'll notice that our output in this case will be x is less than or equal to 10. Why is that the case? Here, we have defined the value of x to be 10. Double x is equal to 10. Then here we are saying, let us test a condition. If x is less than or equal to 10, then we output x is less than or equal to 10. So what if we come here and remove this one and say, we now want to check a condition if x is less than 10. Remember, less than 10 means anything below 10. So if we run this particular program now, it doesn't give us any output because we have not told it what to do in case the condition happens to be false. What if we still retain x less than or equal to 10, but now we change the value of x to something like 15? If we run this particular program, still it doesn't give us the output, it doesn't give us any output because it is so limited to an extent that we have not told it what we wanted to do just in case the condition is not true. So we have only given it an option to perform a certain action when the condition is true. So what is this program doing? This program is evaluating this particular condition against what you have provided it and performing the action enclosed in this particular curly brace where the condition is true. And where the condition is not true, then it does not perform that particular action. For instance, if now I come here and change this one and say x greater than 10, in this case, our value here, x is equal to 15. And here we are saying that we want to evaluate x greater than or equal to 10. If I run it, it's going to give me the output. Now in this case, we need to modify the output here. Or maybe we can just change this output and say, yes, like that. Then we can just run it and you can see that is able to give us the output. So this one is so limited because it's only considering a condition and performing a set of action only when the condition is true. So what about when the condition is false? That is when now the next decision structure comes in, which is known as the if-else decision structure. So now what we need to do here is to introduce something known as an else block that will handle any situation where the condition is not true. So we come here and say else, put the body, and inside this body, put your statement. Then you can say system dot out dot print line. Then you can put no. So you can come here now and say double x is equal to 15. If x is greater than or equal to 10, then output yes. Else, meaning that if that is not the situation, anything else apart from that, output no. So if we run it for the first time, x is still 15, so it gives us yes. If I change this one and now have x as 5, and I run it again, now it will give me no. So this is quite a good improvement because as we can see, it is able to tell us, now it is able to give us or perform an action when the condition is true and also when the condition is false. Let us work with another example now, still utilizing scanner so that you can still refresh what we did last time. Now let us take a situation in which you want to prompt the user to input their age. You want to prompt the user to input their age, and then you classify them as adult if they're 18 and above, and minor if they are below 18 years. So in that case, you would come here now, and first you create an instance of scanner. You can say scanner SC is equal to new scanner. Then you can say system.in. You can see that. Then you can say SC dot next. Maybe you can first declare the value of age, or we first prompt the user to enter the age. So we say system dot out dot print line. So please enter your age. Please enter your age, like that. So this one is a message that the user will get. Then whatever the user inputs, we can come here and now put it at a variable known as age. So we can come here and say double age is equal to, so what do you want the value of age to be, whatever the user inputs. So we take this instance of scanner, and then we pass to it a function known as next double. This function known as next double, if you remember very well, will capture whatever the value has been inputted in the keyboard. Now, after doing that, we come here and put our control structure, the decision structure. So we say if, show the beginning, then we put the condition and say age greater than or equal to 18. All right. We put our body there, and in this body we say system dot out dot print line dot print line. In this one, we can say if greater than or equal to 18, we can say that this one is an adult. Then where we have a minor, we can say else system dot out dot print line minor, like that. So now when I run this program, what do I expect? I expect that here I'll be prompted to input my age. Then it will take whatever I have inputted, pass it through this control structure, and check if the age is greater than or equal to 18, it will output adult. If the age else, that means that anything below 18, it will output minor. Note here that I'm using greater than or equal to 18. If you don't use the equal sign here and you just use greater than, then it means that 18 will still be considered to be a minor. So you have to be very cautious how you're using these assignment operators. The greater than and equal to sign, I believe these things that you did in mathematics. So you can run this particular program, and it tells you please enter your age. So for the first instance, let me enter the age of 20, and I click enter, and you can be able to see here that it has outputted adults. Let me run it again. Now in this case, I input the age of 18 and click enter. You can see that it has outputted adult still because it still satisfies our condition. Let me run it again and now input the age of 17, and now it says that this is a minor. And you can be able to see that. So we have so far done a control structure, two of them, the if decision structure and the if else decision structure. And you can already see the key differences between the two, that the if else is an advancement of the if. And you can also see how you can be able to combine the knowledge on scanner class with the control structures. You can see how they are marrying together. Now, this is still limited because it really doesn't mean that everybody who is below the age of 18, they can fully be classified into the same category. We have infants, we have children, we have teenagers, and even above 18, we have the youth, we have people known as senior citizens, and we even have past 35 years, people are not necessarily considered to be youth. Maybe you can call them adult class 2 or adult class 1, maybe whatever you want to give them. But let us just come with a very simple classification criteria as shown in this particular table. And in this classification criteria, what we have is that between the ages of 0 to the ages of 10, we are going to say that these are kids, basically call them kids. Then between the ages of 10, the ages of 17, or let's say up to the age of maybe 17.9, we can say that these kids are or these people between this age, we can consider them to be in the adolescent age. Now, between 18 to 35, these ones we can consider them to be in the youthful stage. And then between 35 to around 65, these ones we can consider them to be in the upper working class limit. And above 65, we can consider these ones to be senior citizens. So how would we go about that? So this is how you'd go about it. So first and foremost, what I'll do is that I'll come now and fetch this one up to that point. And let me also delete this curly brace so that you don't get confused. And remember, the rule of the verb in Java is that every open curly brace must be closed. That's why if you have an extra closing curly brace which is not paired to an opening curly brace, you get an error. So we start by creating the first condition. We say that if, now here age, we are talking of age greater than 0, assuming age starts at 0, and right, age less than 10. Maybe you can talk of let's talk of less than 10, or let's talk of less than or equal to 10. Then what do you want to do with this one? So you can say system dot out dot println, and we call these ones kids. Then we go to the next category of people, and in this one we say else if. Notice the difference. Here we are not using else, we are using else if. Why are you using else if rather than else? Because rather than terminating and saying anything apart from the condition that we have first tested here, here we are introducing another condition. And that is why we are calling it the multiple if-else selection structure or decision structure. So we're introducing another condition, and our condition 2 here is where age is greater than 10 now, age is greater than 10, and that same age is less than 18. What are we calling these people? We say system dot out dot println. We can say that these ones are in the adolescent stage. Adolescent stage. Then we go and create the third condition. So we say else if. Now we work with age being greater than 18, right? And the same age now here being less than, sorry, here there's a problem. This age greater than 10, yeah, it's greater than 10, yeah. And the same age here being less than 35, yeah, we are okay. We open the body and say these ones are in the youthful stage. System.out.println youthful stage. All right, then you can terminate there. We go now and create our next condition, and we say else if, all right, age, now in this case we work with age being greater than 35, right? We can talk here you should introduce greater than or equal to 18. Here we should introduce greater than or equal to 35. Greater than or equal to 35, all right? And this same age less than 65. Less than 65. What are you supposed to get? We can get here that these people, we can classify them as senior working class. All right, like that, because they are in the advanced stages of their careers. Then you say else if age greater than 65 can talk of greater than or equal to 65 after somebody has retired. Then you can come here and say system.out .print line, and then we can give these people a tag like maybe senior citizens of their respective countries. These are very important people in the society. So that is it. You can be able to see that so far we have been able to include all these figures. So we'll start here and explain our program again before we execute it. So we are prompting the user to enter their age. Then we are capturing whatever they have entered and assigning it to a variable known as age. Then we are saying we want to classify people according to their various clusters. Between the ages of 0 and 10, those are kids. And above 10 but below 18, those are in the adolescent stage. And above 18 and below 35, those are considered to be in the youth stage. And above 35 but below 65, those are considered to be senior working class. And above 65, we can just call them senior citizens or elderly, but senior citizens serves to be a little bit more friendly. Now, having said that, we are using control structures to do that. So far, we have seen the if-else control structure. And in this case, now we're using the nested if-else. So we start with explaining the first condition. So we create a condition here and we say if age greater than 0. That is the starting point, age greater than 0. And these ones, we call them the add operator to combine the two segments of the age. And age less than or equal to 10. What do you want to do with that condition? If this condition is true, then print kids or output kids. If this condition is not true, what are you supposed to do? Test the following condition on the second condition. And now to test the second condition, we use the keywords else if. Now here you say age greater than 10 and age less than 18. So you have somebody who is above 10 years but below 18 years. That somebody is considered to be in the adolescent stage, if that condition is true. Where still the age that you have inputted does not fall within that bracket, what do you want to do? Test the third condition. And in this case, that condition is age between 18 and 35. And that is the youth stage. If that person doesn't belong to that particular bracket, test the fourth condition. And if the person still doesn't belong to the bracket in the fourth condition, test the fifth condition, which says that where the age is greater than 35, then in that case, 65 rather, in that case, that is considered to be a senior citizen. But now, somebody may decide to input something like 0.5 as the age. So what are we supposed to do with that? We can use a limiter here, and we just need to write an else block here that gives an output for anything else that is not within the captured conditions. So we can say else system.out.println. Then here we can say invalid age. So anybody trying to put an age that is not within our captured conditions, that age will be considered to be invalid. But I want to show you something here, very critical. But before then, let us first test our program. So we run it. It tells you, please enter your age. So I'll start with the first one. I enter age 2. It tells me those are kids. I run the program again. Now in this case, I enter age 10. It tells me those are still kids because remember our condition, less than or equal to 10. I run the program again. I enter age 11. That is in the adolescent stage. I run the program again. I enter age 25. That is a youthful stage. I run the program again. I enter 45, working class, it's doing quite well. I run the program. I enter 70, senior citizen. Now watch this. I run the program. I enter age 3000, senior citizen. So technically speaking, it is considering everything above 65 years of age to be a senior citizen. But logically, we know it's very difficult to live past 3,000 years. So you can decide to limit that and you say maybe past a certain given age, the age will consider to be invalid. But now in this case, I don't want to limit the lives of people. In Japan, they are living up to 120 years, so I don't want to put a limiter there, but you have seen how it works. So this one is a very ideal situation. And I must say that this control structure, or the ones that we have talked today, the decision structures, are the power behind some of the basic tools that we use in software today. Something like a login page uses the decision structure just to fetch your data from the database and compare it against what you have given. And when it compares against what you have given, it is able to tell whether or not you have given the right information. So now the next thing that I want to do, we have worked with numbers here. Can we be able to compare now text? Can we be able to create decision structures, or can we be able to make decisions given text? Let us do exactly that. So first and foremost, you make sure that you clear everything. After you have cleared everything, now we go ahead and we first start the basic one, whereby we are defining a static string. Then we go to where we are requiring the user to input the string from the keyboard. Let's take a situation of a username, like the one that is used in a login page. Maybe you can define a variable like a string username is equal to, maybe we can say that our username is this one, yeah, which is the channel's name, Kameritech. Then we can come here and say if username, right, is equal to, then you can put some quotation marks there and say Kamiri tag like that. Then you put your body. Then you can say system dot out dot print line login successful. And say maybe login successful. Then you can come here and say else. We can just copy this one to save on time so that you don't have a very lengthy video. I'll say this one, you just paste it here, and we say login failed. So let us test it. So if I run this one, you can see that the text that I have over here and the text that I have over here is the same. So here, what I have done is that I have defined some static text, which is a username, and I've called it Kameritech. Now I want to verify if username is equal to Kameritech, then what do I want to do? Perhaps I want to output login successful, else I want to output login failed. So if I run this one, you can see that the text is the same, so it says login successful. But we say that Java is case sensitive. So if I change this T from uppercase to lowercase like that one, and then I run it again, it will tell me that login failed because the two do not match. What about situations in which now we want the user to input from the keyboard? I want you to observe two situations here. Here we are using two equal signs. These two equal signs, we mainly use them in situations where we have an already defined static text, like we have over here, defined here as a variable. But when we want to input from the keyboard, we use the dot equals method. However, in some cases, you'll find them working interchangeably, but that is not a very big point of discussion. But just know that it's ideal for you to know which one to use at what point. For static text, you can use the two equal signs. For dynamically changing text, you can use the dot equals method. So if you are to use the dynamically changing text, this is how your program would look like. So you'd come here and now introduce a scanner, then tell the user to enter the username. Then you create a string known as input, and then you use a method known as sc.nextLine. Remember, when we are dealing with numbers, we are using sc.nextDouble. But in this case, we are going to use sc.nextLine because we are dealing with text. Then we put our condition, we say if input.equals veritech, then login successful, else login failed. Then you can use csc.close. That one is optional. You can put it or decide not to put it. So if I run this one, it will prompt me to input my username. In this case, I'm going to try and input the right one. So I'll input Kameritech like that. It will tell me login successful. If I run it again, let me now input the wrong one. I just input one name to tell me login failed. And that is how you deal with control structures when you have text data. So you can see in a very abstracted way how your login page is created, and we shall get to creating an actual one when we get to the event-driven aspect of Java, and when we'll be creating GUIs using Java. So for now, that is it for this particular part 4 of the series. In part 5 of the series, we are going to advance further. We look at loops and we look at nested control structures, and then we'll be able to create more advanced programs. Thank you so much. Continue subscribing, like our videos, share them, and in case of any comments, put them in the comment section below.